شباب إن شاء الله we will continue our discussions on stepper motors. Recently we discussed the variable reluctance stepper motor. We discussed the operation at full speed or full step operation and half step operation. And we compared already between the full step and half step operation and which one has higher power and what is the torque shape and so on. Today, inshallah, we will discuss similar things but for a permanent magnet stepper motor. So the objectives of today's class, inshallah, is to understand the permanent magnet stepper motor operation for unipolar and bipolar. So this will be the main objectives today, to understand the operation and construction for unipolar stepper motor and bipolar stepper motor, and what is the meaning of unipolar and bipolar motors. First, شباب, regarding the construction of permanent magnet synchronous motor, one of the most well-known permanent magnet stepper motors consists of two phases. As you remember, in variable reluctance stepper motor, شباب, we said that number of phases, number of teeth are variable. You can change it as you need according to your design. However, for permanent magnet, it's almost fixed, and the market has well-known design for permanent magnet stepper motors, like what we'll discuss inshallah today. So we have now two phases in stator side and 6 poles on rotor side. Take care, here we said 6 poles, not 6 teeth, like in variable reluctance, because here the rotor will be cylindrical type, which means the air gap will be uniformly distributed between stator and rotor. Okay. However, you know, there will be a saliency due to the permanent magnet itself. And if you would calculate the reluctance of such motor, you will find that it's like salient pole. Why? Even if it is not a variable reluctance, however, due to the pole inserted in the rotor structure itself. Okay, so the rotor here is cylindrical and has some poles. Stator has 2 coils wounded on 4 teeth, like we will see inshallah. Okay, and the windings can be in one of these shapes. In figure number 1, as you can see here, we have coil AB, or coil number 1 has terminals AB, and coil number 2 also has terminals AB. So if we would assign this terminal here, we will say 1A. If we are going to assign the terminal or the pole connected here, we will say 1B. Which means, in other words, we have coil divided into half coils, and the midpoint here will be the tab of this coil. So here, شباب, in the unipolar, this is for unipolar motor, we are going to consider energizing 1/2 coil or 2 halves. If you imagine with me, if we supplied this coil now, connecting positive volt to terminal 1 and connecting switch here to ground and another switch here to ground, like that. Now, if we close this switch, شباب, the current will flow in which direction? شباب?
From left to right.
Now we have 1 and terminal A, then a switch and connecting to ground. If we turn on this switch, which means the switch is closed now, and the other one is open. So the current will move from positive to negative, شباب. Is it right? It's DC.
Yeah.
So the current will flow now in only one half of the coil. Is it right? صح يا شباب؟
Yes.
طيب. If we opened this switch and closed the other one, the current will flow in the opposite direction like that. طيب. Which means يا شباب, the terminal A will receive the current. And the same is also for terminal B. For that, the tooth at the end A and the tooth at the end B will see the same direction of current, which means it will see the same direction of flux as well. This is going to make polarity for all of poles in this configuration to be like N polarity, only north. So the energized one will be north only. North at the end of the pole. And the beginning of the pole will be on the other point of the half coil. So in this case, the end of any tooth will have only one polarity. For that, we call this motor as unipolar. Again, يا شباب, in a motor, we have, this is structure of the motor, and here we have the tooth. So for this tooth, the end of the coil will affect the tooth here as N. And for sure, the winding is made like that. So the other part here will be S. So this means you have the end of tooth itself will be only N. So it's unipolar teeth now. The unipolar motor has unipolar teeth with one polarity. So the flux now will go from the tooth and will interact with the rotor. Okay, but taking in consideration, you have only single polarity at the end of tooth. For that, we call this type as unipolar. However, for the bipolar motor, we have similar two coils, but without center tap. As you can see, we don't have midpoint and terminal for the center of coil, which means the current can flow from 1A to 1B or from 1B to 1A. So the tooth at the end 1A can receive current, or the current will leave this point, which means the polarity of current or flux as well will be now variable. It will not be constant or one flux or one polarity. So we can operate the tooth 1A with two polarity now. So we call this type as bipolar. How we can reverse the current direction? By means of 4-quadrant DC chopper, like what we already discussed in DC motors. So 4-quadrant DC chopper, which we call it, شباب, by the way, H bridge or full bridge. It's like that. And this is a simple representation for the H bridge. And here we will connect our DC supply. So we may have S1, S2, S3, and S4. So now, شباب, in order to flow the current from 1B to 1A, we need to turn on S1 and S2. If you would like to reverse the current to move from 1A to 1B, So you need to turn on S3 and S4. So this is the way how we can reverse the current in the bipolar stepper motor by means of H-bridge. So as you can see, يا شباب, one coil will need 4 switches. However, in unipolar, one coil needs only 2 switches. So the power electronic circuit or drive circuit used for unipolar is simpler or cheaper than the one used for bipolar. Because here you have 2 coils, so you have 8 switches. But here you have 2 coils with only 4 switches. So twice of the power electronic circuit components. So this is now, شباب, the construction of unipolar and bipolar stepper motor. And if this is not very clear, you will see it inshallah in the example. Here, this is the structure of our motor, unipolar stepper motor. So we have 1A or A1 and A2, which means now one half of coil will be wounded on this tooth, and the other half of coil number 1 will be wound on the other tooth. So if you energize now the one half of A1, it will make this polarity as N. طبعا if it is N, it will interact with the very closing A S pole. Now this is our rotor structure, يا شباب. It's cylindrical type, and we have inserted poles like that. Okay, so we have 6 poles, okay, or 3 pair poles in rotor, okay, and we have 4 teeth in stator side like that. So this is now, شباب, the first position. When we energize the one half coil 1A, so the meaning now that we have, this is the point 1, and we have one half of coil already wound here and connected to switch to ground. Sorry. Connected by means of power electronic switch to ground like that. And the other half of the coil is connected to the other teeth and through switch to ground as well. So if we energize coil A1 or half coil A1, this means we are going to turn on this switch, and the others will be open circuit. So this is now the sequence of pulse configuration here. 1A is active high, and the others are 0. And let's assume the first operation or first step as reference, like what we made previously. When we need to energize now another another tooth, for instance, B1. Let's see together what is the possible tooth that we can energize. Now, شباب, if we need to energize, or if we need to move the motor in that direction, which tooth can be energized? B1 or B2?
B1.
If you energize B1, this means B1 will be N. And if this is N, it will interact with S or attract the pole S. And in this case, the motor will rotate in this direction. This is completely right. Thank you, Hisham. طيب. If we need, شباب, to reverse the motor operation, which means to move the motor in the opposite direction, so we should supply B2. طيب, why, يا شباب, when we supply B1, the rotor moved like that? Why not this pole coming here? Because this is N and this is N, so there will be repulsion, not attraction, between these two poles. For that, شباب, take care about unipolar or bipolar, because in bipolar you will have two polarities, N and S. But here you have only single polarity because it's unipolar motor. So N here, شباب, means when we energize the B1 half, which is this shape now. So when we energize B1, here will be pole N, and it will attract the pole S, and the motor will move 30 degrees in this direction. Again, يا شباب, from this step, if we need to move the motor for one more step of 30 degrees. So, which half coil should be energized now? ها شباب?
To the next step, you mean, Doctor?
To the next step, yes.
It will be A2.
تمام. So if we energize A2 now, it will attract this pole S and it will move another 30 degrees. So this is now the shape, and so on, يا شباب, by the same way. So the sequence for full step in unipolar case, the sequence is 1A or A1, B1, A2, B2. Then we will repeat again the sequence in order to move the motor for complete one step. So for complete one step, يا شباب, يعني starting from 0 up to 330, طبعا last step which is 0, which is 360. So it needs 16 pulses now. All of time, يا شباب, for 30 degrees step angle, you will need 12 pulses per second. صح يا شباب? Sorry, pulses per revolution, not pulses per second. Pulse per revolution. So, this is for unipolar operation. Can we operate this motor in half a step to move in 15 degrees instead of 30 degrees? Is it possible?
I think no, because we have unipolar.
طيب, يعني in terms of mathematics, we said, or logics, we said last week, or last class, sorry, if you make O-ring for the two successive steps in full step, you will get the half step. Let's see if this rule is going to be already considered here or not. يعني if we make OR gate between these two steps, it will be 1, 1, 0, 0, which means A1 and B1 are energized. But let's see A1 and B1, which means now this is N and this is N as well at the same time. So is there any objection, يا شباب, to make the rotor moving only 15 degrees and the poles S will be in midpoints between the two poles? And here we have angle between the two successive S poles of 120. And the two N poles in stator, the angle is 90 degrees. So the rotor can go in the middle between the 90 degrees, and in this case, S pole will be only 15 degrees shifted from A1, and here this S will be shifted from B1 by another 15 degrees. So why not? Huh? It's possible, شباب, is it right? It's possible. So يعني, this is now the configuration for half step. We made like what we said, just making OR between the steps of the full step, the first two steps in full step operation. So 1 0 0 0 and 0 1 0 0, just making OR for the pulsings here. So you will get 1 1 0 0, and you will see that the motor has moved only 15 degrees. So it's possible also to move the motor using half step operation for the unipolar stepper motor. طبعا if you now removed the pulse on A1, it will be returned to the 30 degrees position, and so on. So by the same way, we can continue operating this motor at half step. if we compare now يا شباب we have step different pulses or different steps. As you can see now, there is interaction between flux in this side. However, here there are two interactions, one in this side and the other in that side. So what do you expect, شباب? Which one has higher torque or power? In the first step or in the second step? ها شباب.
The second one.
Second one, for sure. Why? Because we have now, as you can see, the rotor itself is bonded from two sides, not only from one side. So we expect to have higher torque here. And higher torque is nothing but higher power. So here you can have higher motor power. Okay, شباب? So this is one advantage of applying two half coils at the same time. And again, if we compare the operation in half step, you will find the torque is pulsating now, because torque here in position, in reference position, is smaller than the torque in that position. Okay, and so on, شباب, the sequence operation will be continued until reaching to the 345 degrees. Okay, and if you change or continue the schedule, you will go again to the first step, okay, which is the reference angle. So this is a way to move the unipolar stepper motor in half step operation. طيب, bipolar motor يا شباب. We said in bipolar we have complete coil energized, and in this case the first half of the coil will be N polarity for instance, and the other one will be S. So for instance, شباب, or firstly here, the sequence or the table writing will be different. Instead of saying 1 or 0 or energized or not energized, we are going to assign the polarity of the half coil or the tooth itself. Yani firstly, when we need to energize A1 as N, we will say this is N. And the opposite tooth will be S. So A2 will be S. However, in the beginning, for this step, we will not energize coil B at all, yani either B1 or B2, because all of coil tooth will be energized together. So coil 2 now will be 0. I think يعني طيب معلش يا شباب, يعني there is a يعني typo here, but the typo is in table and figure as well. So يعني let's make a name for coil instead of 1A and B and 2A and B. يعني if we have one coil like that, we are going to say coil number A and coil number B instead of 1A and B. So coil A has terminals A1 and A2, okay? And the other coil will be coil number B with terminals 1 and 2. So in this case, we have coil A, terminal 1 and terminal 2, okay? So the name is different a bit compared to the previous one. For that, you will find coil number A, terminal 1 is energized as N, and the other terminal has to be S in this case. Okay. If you compare this sequence with the one in unipolar, you will find instead of N, there was 1, and others were 0. صح يا شباب؟ يعني let's return back again to unipolar case. Remember here it's N0S0. We said it's similar to 1000. So for here, as you can see, first step was 1000. Second step is 0, 1, 0, 0. So let's go to the bipolar here. 0, 1, 0, 0. And unipolar 0, 1, 0, 0, which is equivalent to 0, n, but not 0, 0 because the end of the coil has to be opposite to the beginning. So instead of, in order to not be confused, شباب, you can memorize that you are going to replace the ones in unipolar operation by n. And for sure, if you energize the first half by n, the other half has to be s. So this is the way how to memorize the operation in order to not be confused. So in this case here, all of time take care in the schedule, take care about n. As you can see, n will be shifted in this way all of time. Okay, شباب. So n will be instead of active high, and s will be the other terminal, and take care the other coil will not be energized at all, which means it's 0. So by the same way, شباب, the operation will be the same now. But let's discuss in more detail the operation. So first sequence, we have A1N, so this is N now, and A2S, so this is S, and other coil tooth are not energized because the other coil B is active low here, which means it's not connected to supply. So we expect to have interaction between the rotor N and S, stator N and rotor S, and in the opposite side it will be also the same between N and S. So the rotor here is coupled from two parts or two sides. If you apply the second pulse B1N, so this means B1 here will be N. So this N will interact with this S. And by the same way, if this one is N, so the opposite teeth has to be S. So it will interact also with this N and rotate this rotor by 30 degrees to be like that. So this is the second position. And as you can see, the rotor is also coupled between or from two sides. So comparing now, شباب, between the full step bipolar and full step unipolar, you will find that bipolar has higher torque. صح يا شباب؟ يعني in unipolar for full step operation, the rotor was connected or coupled only from one side. So this is now the unipolar again. For all steps, as you can see, rotor is coupled from one side only. And the other three sides are not energized. This is in unipolar. However, for the full step in bipolar, all of time the rotor will be coupled from two sides, which means now the torque for bipolar machine is higher than the torque in case of unipolar. This is for full step. Again, شباب, if we need to operate the motor at half a step, similar to what we already made before, if we make O-ring between the first two steps. But take care here, N and 0 or N or 0 will be N. Okay, because N is already polarity. So here we will have N, okay, then 0 with N, it will be N as well, okay, and this will be S and this will be S. So you have now N, N, S, S in between 1 and 2. What will happen? Let's see this clear here. So we have this half step operation. We have N, N, S, S. So this is N and B1 is N as well. So this is also N and others will be S. So as we made before, this S and that S will try to interact with the poles N. So the rotor will move in order to make the rotor position in the midway between the two successive teeth of the stator. So in this case, شباب, the motor will move only for 15 degrees. So this is now the half-step operation for bipolar permanent magnet stepper motor. So for this case, شباب, the number of pulses per revolution will be 24 because we moved only 15 degrees. And comparing to previous cases, you will find that the torque is pulsating also. Why? Here we have two sides of interaction. Here we have four sides. So the power here is the maximum, شباب, is the maximum ever power for stepper motors, because the four stator teeth are interacting with rotor now. So this is the maximum possible power we can obtain from stepper motors bipolar in case of using this type. طبعا يا شباب, يعني it's not a condition to use it only for half a step. يعني we can use this configuration for full step. How? Just selecting these angles or these steps, this one, that one, and so on. So in this case, you will find in each step you will energize the all coil. So four tooth are energized. Okay, for the selected steps here, okay, you will find four tooth are the four teeth are energized. تمام? So the maximum possible power can be obtained in permanent magnet stepper motor in case of bipolar half step or full step if we consider this sequence. يعني this will be first step, second step, third step, and so on. تمام? So this is the way, شباب, how we can increase the power or moving the motor in half step operation. Is it clear, شباب? Different configuration now in permanent magnet bipolar motor or unipolar motor. Is it clear?
Yes, it's clear, but I have a question, Doctor.
تفضل.
What is the benefit for bipolar? يعني?
Comparing to unipolar or
yes.
Oh, okay. For unipolar motor, you have only rotor coupled from two sides at most. صح ولا غلط؟ يعني for unipolar, if we return back again, we said the maximum power can be obtained if we energize two half coils. صح?
Yes.
However, in case of bipolar, you can energize now the two coils together, and this will make bonding or coupling for rotor from four sides, not only two sides. In this case, you will have high power. So the benefits of using bipolar is the higher power. You can make higher torque and higher power. This is why the bipolar is used compared to unipolar to obtain high power. And also, in general, permanent magnet compared to variable reluctance, it will also make high power or can be used for higher power. Okay. Now, we have some notes regarding the operation, like what we made in variable reluctance. To reverse the motion direction, the sequence of pulse has to be changed from, instead of A1, B1, A2, B2, it will be A1, B2, A2, B1. يعني طبعا this will be very clear from the table يا شباب. If you reverse the sequence, you can rotate the motor in the opposite direction. For the full step operation, only one half coil is energized. طبعا this is for unipolar. Okay. To operate the motor at half step, you need to follow the following sequence: A1, then A1 and B1 together, then B1, then B1 and A2, and so on. So this is the sequence that we can use for half step. These nodes شباب are for unipolar. Okay, and up till now all of these are considered for unipolar, or this part, not all of nodes. Okay, so all of these now are considering unipolar motor. Then the torque produced by bipolar motor is higher than the torque of unipolar motor طبعا according to يعني common operation. يعني if we compare between full step in unipolar and bipolar, or half step in unipolar and bipolar, you will find all of time bipolar has higher power because of the higher torque. Again, the torque produced by half step is pulsating torque, and this is considered one of the drawbacks of the half step operation. The torque is pulsating. Now, شباب, regarding the power circuits used in unipolar motors, this is the typical circuits that can be used for unipolar motors. So as you can see, we have here our coil made in two halves. This is the first half, and this is the second half. And even here we have different names, يعني A and A prime. Okay, يعني whatever the naming يا شباب, يعني it has many names. It's not standard. Okay, but mainly we have common point will be connected to positive supply, and the other ends of the half coils will be connected to switches like that. But we need like freewheeling diode for protection شباب in this circuit. So يعني it's not only 4 switches, we need 4 switches and diodes as well. Okay, so this is the typical circuits used for unipolar permanent magnet stepper motor. So as you can see, this is now the first coil. The second coil will be made by the same way. So finally, you have 4 branches. Each branch has switch with antiparallel diode, either MOSFET or IGBT or whatever, and just one single diode. And you need 4 branches from this circuit. طبعا شباب, يعني this circuit is very simple. Also, in terms of driver circuits, and inshallah we will discuss in detail the meaning of driver circuits in variable speed drives. In terms of driver circuits, you have common emitter, or if it is MOSFETs, you have common sources. You know يا شباب, the terminals of MOSFETs, terminals are drain, gate, and source. These are the names of the 3 terminals of MOSFETs. As you can see, شباب, S for all of the circuit MOSFETs are connected to the same ground, which means now you don't need any isolation for this circuit, and this is already يعني this is good because of the cost of isolation, and DC power supplies will be high if you don't have common ground or common sources. Okay, so this is considered very cheap circuit now, because no need for isolation, as you have common sources for all of switches. This is not the case for the other circuit of bipolar. We will see together the bipolar circuit. So we agree now, شباب, this circuit is very cheap. Even you can make it by your hand, just 4 transistors that can carry the required current, and just 4 diodes, and no any other needed equipment. Only you can use transistors for power supplying the gates. This is all you may need in order to draw the current from a power supply, not from microcontroller for sure, because you cannot draw high current from microcontroller. This is regarding the gate current. Okay, and you can make simple, very simple circuit like that, just transistor, with resistance like that, and this is a VCC, which will be the supply of gate, and just take the output here to the gate of the transistor. And this is here can be connected to your microcontroller. Why? If you just connect this to microcontroller immediately, the gate current here may be high. It's according to the power of the transistor itself. Sometimes, شباب, the peak current of this gate reach to 2 amps, 4 amps, like that, but for very small period. So the energy will be high, and it cannot be drawn from microcontroller. So you have just to make very simple circuit like that. Just a transistor with very small, and not high power, just small power, in order to absorb the gate current from this supply, from VCC here, okay? Not from the microcontroller. And as we said, in this case, you will need a transistor for each MOSFET, for each power switch, okay, with common supply. You don't need to have separate supply or separate grounds, because as we said, ground here or sources are common for this circuit. Is it clear يا شباب؟ طبعا implementation of such circuits is very important in graduate projects يا شباب. ماشي يعني most of you will make يعني such circuits for graduate projects, so you have to be familiar how you can use electronic equipment and microcontroller in order to avoid any problem or burn any component. في سؤال يا شباب؟ Any question? Regarding the power circuit of bipolar. Now, as we said, in order to reverse the current in coils like that, in this direction or in the opposite direction, so you need to have one full bridge for each coil. For that, here we have Q1, 2, التسمية مش واضحة بالنسبة لي. 5, 6 تقريبا. 5, 6. So Q1 and the Q6 will be used for this direction of current. Q2 and Q5 will be used for the opposite direction of current, like that. This is for the first coil. The other coil will be the same. So, in order to operate this circuit, شباب, you need 2 full bridges. يعني it's not very expensive now يا شباب. يعني by the way, يعني this circuit can be obtained if you have a current around 2 ampere and up to volt of I'm not remember 12 or 24 volt, like that. يعني 12 يعني 24 or 12 volt. يعني the cost of such circuit شباب يعني is only around 30 50 reals, like that. It's very cheap now. Okay. However, for high power and high voltage, that will be يعني somewhat expensive compared to this price. يعني for instance شباب, if you would like to buy the same circuit for high voltage 600 or 1200 volt, يعني the cost may be for the 4 branches maybe reach to $100, like that. So in this circuit شباب, we have to يعني consider that the source, which is this terminal of MOSFET, يعني for all MOSFETs شباب, all upper MOSFETs, okay, the source for the upper MOSFETs cannot be connected to the same ground, because if you make that, it will short circuiting the coils. So you cannot connect all of these switches to the same ground of DC supply of pulses. I mean, for the control circuit, for the driver circuit, you cannot use the same ground. However, for the lower switches, you can use, because they are already common sources. But for the upper switches, sources are different points. so you cannot connect them to ground together. Otherwise, you are going to make short circuiting on all of the circuit. So here you need special circuit and drivers. You have to make isolation, and also you have to make dead band. And we will discuss, inshallah, the meaning of dead band and isolation circuit in details in the part of variable frequency drive. So, the conclusion here, the circuit of bipolar is expensive compared to unipolar motors. Why? Because it needs some special consideration like isolation, okay, and the number of switches also here. Even with this small price, yes, comparing the actual price now for unipolar, maybe 1/2 or less than 1/2 of this price. Which means it's very, very cheap. Transistors are very cheap. Okay, switches for low power are very cheap, so you can easily implement your circuit with very competitive price. According to our understanding now, Shabab, this is the last take-home exam instead of quiz. It will be also for stepper motor now. So you have already take-home exam, which will be today, Shabab, inshallah, available after our class up till the end of today. Okay, the end of the day. This is regarding universal motor, and inshallah we will make another quiz for stepper motor as a take-home exam as well. Okay, and we can agree with the time, inshallah, after finishing the class together. But let's see what is required here. Okay, it's not like universal now, it's like homework, Shabab. Because you already know the exam, so I will make it as assignment. Okay, it will be like an assignment or homework for on Blackboard. 3-phase stepper motor shown in figure. So this is the 3-phase stepper motor you have. As you can see, it's variable reluctance 1. It's supplied from a chopper to provide the proper full step operation. We discussed the Shabab last class the circuit used for variable reluctance motor. And as you can see here, you have coil number 1, which means now this coil is supplied or used to move the current between supply to ground by using only one switch. So you need now one switch for this phase, and other 2 phases needs the other 2 switches, and so on. And the circuit is already discussed in the previous class. So the chopper is connected to a supply of 24 volt and drawn current per phase of 0.2 ampere. So this is now the average current per phase. If the chopper is controlled by switching frequency of 500 Hz, so this is your frequency now, calculate the motor speed, the step angle, the number of step per revolution, and the consumed power. Considering the duty cycle for the 3 phases, which means you are making pulses for the 3 phases, and these pulses are shifted. Okay, and it's not connected at the same time because you are not going to energize the coils at the same time. Why? Because we said here it's full step operation. It's just very straightforward the problems of variable reluctance motor to understand how you can calculate the power, frequency, speed, step angle, and so on. Okay. So this is just a summary now, Shabab. We discussed now the types of permanent magnet stepper motor, the operation of different types of stepper motor, and the power circuit needs for all of motor types. This is all what we have, Shabab, for stepper motor. We did not cover one of the types of stepper motor, Shabab, which is hybrid. يعني hybrid stepper motor is used a lot actually in the applications today. However, the construction is complex a bit, and the analysis are also complex, so and it's not easy to be covered in our classes for the remainder time. So we'll consider only the two types we have discussed, variable reluctance and permanent magnet. And the idea of hybrid will be by the same way similar as we made for unipolar or bipolar or variable reluctance. It had the same idea. However, just the difference is in the analysis. Okay, analysis is different a bit, and it's made computerized using mathematical models. It's not easy to be calculated by hand. Okay, and the step is very small compared to that operation we have discussed here. Okay, we may have 0.15 degrees step angle in hybrid stepper motor. So the typical step for hybrid is very, very small, very fine step. Okay. So we will stop at this part for stepper motor. Okay, and this is enough for stepper motor topic, inshallah. And next class we will start in variable frequency. Any question, شباب? Everything is clear, alhamdulillah.
Yes, clear.
الحمد لله. اوكي يا شباب، يعطيكم العافيه، نشوفكم الكلاس القادم ان شاء الله. بالنسبه لل